What's that? Does it have to be one or the other? Can't it be a function that has a radical in it? Yeah? Okay. What does it look like when you graph it? I know. It's been like 2 whole months since we did this at the beginning of school. Oh my gosh, it's been longer than that. It starts at the origin and it curves weird. Well, you're lucky I actually know what it looks like, right? What's the domain of this function? How far to the left does it go? 0. How far to the right does it go? Infinity. So we say, or we say, right? Either x is greater than or equal to 0 in inequality form, or in interval notation, we say from 0 to infinity. 0 to infinity, 0 is included and infinity is not. Yes? What's the range of this function? How far down does it go? 0, how far up does it go? So y is greater than or equal to 0. Yeah? In inequality notation, what about interval notation? So it looks exactly the same as the domain? It doesn't? But it looks exactly the same, right? From 0 to infinity, 0 to infinity. We know this is domain, we know this is range. But visually, these two look exactly the same, don't they? Okay. What about this one? What's that one look like? Kind of like a S, like a really stretched out S. If any of you wrote your S's that way, that would be confusing, yes? Okay. What's the domain of this function? How do you know that? How far left does it go? And how far right? So all real. Interval notation? Negative infinity to positive infinity, right? All the way left, all the way right. What about the range? How far down does this go? How far down does it go? Infinity. How far up does it go? Infinity. So, all real. Or infinity to infinity, right? Negative to the left, positive to the right. So what are we doing today again? Graphing radical functions. So I chose these two to work on today, square root and cube root, because those are the most popular, right? Okay. Think about cube root for a second. What always goes along with graphing rational or graphing functions? What always goes along with that? Transformation rules. You remember those? Okay. Think about where I could put this on the graph. Could I shift it up and down? Could I shift it left and right? Could I stretch it and shrink it? Does it change the domain and range at all? Because anywhere I put it on the graph, it's still going to go all the way left and all the way right. Even if I reflect it, it's still going to go all the way left and all the way right, and all the way down and all the way up, right? So no matter where I put this on the graph, no matter what kind of transformations I make to it, the domain and range is going to stay all real and all real, isn't it? Same thing happened here? Not this time, right? If I shift it over here, if I shift it left, that's going to change my domain, isn't it? Depending on how far I move it left. If I move it right, that's going to change my domain, depending on how far I move it right. Okay? So if we're doing domain and range on cube root, we got it made. Right? If we're going to do domain and range on square root, we got to think about it a little bit more often, yes? Okay, so let's start with this. We're going to go with our parent being the square root. Okay? So tell me how this changes compared to its parent. So you're saying the right words. Can you use the correct math words? Hold on. Let him try it. Let him try it. Up 3. Vertical shift up 3. You were telling me it moves up 3, but I asked for the correct math words, right? Correct math words means we got to talk about vertical shifts, horizontal shifts, all that kind of stuff like that, right? Thank you for the rest of you being patient with him while he tried to figure this out, okay? You did a good job. What is the domain and the range of this function? Well, if all I did was move it up, does the domain change from the parent? X is greater than or equal to 0 or 0 to infinity. Does the range change if I move it up? If I moved it up 3, how far down does it go now? It stops at 3, right? Or starts at 3, depending on how you look at it, right? So y has to be greater than or equal to 3. So wait, you're telling me, remember how we talked a minute ago how these look exactly the same, right? They don't always have to look exactly the same? Oh, okay, cool. Can I try to trick you? Okay. What about if g of x was the cube root of x plus 3? How does that change compared to its parent? Wait, it's exactly the same as this one? Why? Because of our transformation rules, right? This is outside of the function. It doesn't matter what the function is. If it's outside of the function, it moves a vertical shift up 3. Done. Yeah? What's the domain and range of this new function? Oh, well, this is cube root, right? It doesn't matter? What do you mean it doesn't matter? It really matters if I'm asking you about it. Oh, it stays the same, right? It stays the same as the parent because of the shape of the graph. So it does matter. Maybe not to you, but to your grade, right? Okay. All right, somebody who hasn't talked yet. Let's talk about h of x. What if it's the square root of x minus 4? Like that. Well, where is the 4? That's inside, so... Now, why are you saying right 4? Oh, it's different than what we think, right? We think it should move left 4, but it's inside, so it's different than what we think, so it's right 4. What about the domain and the range? It was here. I moved it here. I'd like someone else to try to answer this instead of the same people answering. Please. X is greater than or equal to 4. Why? Perfect. Interval notation? 4 to infinity. What about the range? Stays the same as the parent because we didn't move it up or down at all, did we? Okay, so y is greater than or equal to 0. Okay. Let's do j of x. Ooh, yeah, that's dangerous, right? What's happening here? reflection over the x-axis because of that negative sign in front, right? And then down 5. Tell me about the domain and the range. So it was here. I flipped it over. I moved it down 5. So now it's there, right? So what's the domain? How far left does it go? To 0. How far right does it go? So x is greater than or equal to 0, right? If all I did was move it up and down, the domain does not change, does it? Whoops. Sorry. That's a bracket. Now what about the range? So y is what? How far down does it go, guys? Guys, how far down does it go? All the way, right? How far up does it go? To -5, right? So it's everything less than -5. What's an interval notation look like? -infinity, because it goes all the way down, all the way up to -5. We got to be careful when reflections happen. Okay? Yes? How about that one? Dun dun dun. So remember, when we do this, order matters, so we got to go left to right. Okay? Now don't answer if you've already answered a question so far. Okay? So somebody who hasn't answered a question so far yet, tell me the first thing. First thing? Reflection. Over x-axis. What's next? Is it a stretch or a compression? Stretch, why is it a stretch? It's bigger than 1. So by a factor of 4. What's next? Right 1. And vertical shift up 6. Now, is that hard? No, just 4 things instead of 1 or 2 like before, right? What's the domain? And what's the range? Some of you can do this without graphing it, can't you? Like you can see it in your head, but for the rest of you, does it help when I graph it for you? Okay? So if it helps when I graph it for you, don't you think you ought to graph it on your homework? Okay? Am I doing anything fancy? Like, am I getting the calculator out and getting exact measurements? No, I'm giving myself a sketch to look at, right? So it started here. That's my parent. I reflected over the x-axis. I stretched it by a factor of 4. I moved it right 1 and up 6. So it looks like this. Right? So what's my domain? How far left does it go? To 1. How far right does it go? So x is greater than or equal to 1. Or 1 to infinity. Yes? What about the range? How far down does it go? And how far up does it go? To 6. So, y is less than or equal to 6. Or negative infinity to 6. Yeah? Questions?